Today I'm gonna teach you how to draw graphs. Let's not waste our time. As you know, this is x-axis and this is y-axis, and you can see this is the number line of x consisting only, and this number line consisting y only, and all of them are equally spaced numbers. You can see figures not to scale, but ideas are. So we can see these both are 90-degree for our all considerations. Now this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Let's not waste time, we have a lot of things to do. Our first function will be y is equal to x, a very simple one, as you might have guessed, as x is 0, y is 0, x is 1, y is 1, x is 2, y is 2. It's kind of copying whatever the value x has. So the graph is quite self-evident. It's like a straight line 45 degrees to both the axes, and as it is a line, both ends should be arrows, and these are also arrows. Minus x, this is y, this is minus y. So next line, next we'll move on to complex one, y is equal to x square. For y is equal to x square, you will see the graph goes like, there's some kind of basic functions, you must memorize them. And for y is equal to x square is parabola. I should write here whatever I'm spelling. This is parabola, so this is known as parabola, and why it is I'm gonna tell you in a minute, not even a minute. We take the axis, we make 1, 0 as this point, and minus 1, 0 is this point. This is 0, 0, this is 0, 1. As you might have noticed, look, y is equal to x was this. Now for x greater than equal to 0 and less than equal to 1, x square is less than equal to x. If we remove these, this holds. For x square, for x less than 1, all the values of x square are less than x. So let's make this point, this is dotted lines, supporting lines. Sorry, I made this, let's make this dotted lines. So for all the values of x less than 1, x square is gonna be less than x. So x square, y is equal to x square is less than y is equal to x for all the values less than 1. But after that, when x becomes greater than 1, x square becomes greater than x. As you might have noticed that 3 square is greater than 3, but 1 upon 3 square is I'm sorry, less than 1 by 3, as it is 1 upon 9. So now this will go like this, and symmetry lies everywhere. Let's go like this here. So it was kind of easy to draw y is equal to x square in a minute. Now I'm going to get some more complex functions like y is equal to root x. This is more complex than the previous one. Y is equal to root x. If you believe me, y is equal to root x is the inverse function of y is equal to x square. So for inverse function there is a rule. When we draw, we take mirror images of the inverses. So if I had drawn y is equal to x square, and if I had drawn y is equal to x, y is equal to x square, I'm gonna take mirror image on y is equal to x and use your imaginative minds to draw y is equal to root x, and this will be like this. So this is y is equal to root x, but as y cannot be less than 0, I should say that this never exists. So our graph for y is equal to this line is, I'm sorry, this line is 1 comma 0, this is supporting line, and this is 0 comma 1. One thing that you might have noted is y is equal to x, y is equal to x square, y is equal to root x. When x is equal to 1, y is always 1 in all the three cases. So this is the common point of intersection. So I will draw only y is equal to root x now. So y is equal to root x goes like this and like this. So it's just, you got the idea how it is drawn if taken references with y is equal to x square and y is equal to root x. Now we'll go to some more complex functions, not exactly complex but kind of basic. Y is equal to 1 by x. Y is equal to 1 by x could also be written this way: xy is equal to 1. This is not a tough function. If you see, draw a line like this, and whenever you see if y, I'm gonna write values. If x is equal to 1, y is 1, but x is equal to 2, y is 1 by 2, x is 3, y is 1 by 3. It's opposite. If x becomes greater than 1, y becomes less than 1. If x becomes less than 1, y becomes greater than 1. The only meeting point of both of them is 1 comma 1. So I'm gonna rub this. So this is 0 comma 1 comma 0, and this is 0 comma 1. With this point, I'm pretty much sure that the graph will look something like this, asymptotically going this way and asymptotically going this way. This is x and this is y. So it's asymptotically, it's not touching y-axis, it's going asymptotically. Asymptotically means a line is going near to this line but never touches it. It touches at infinity. I might tell you this in another video, but you have to take it that this is asymptote, like this and like this. Same goes in third quadrant. I'm gonna draw like this, I'm gonna draw like this. This is minus 1 comma 0, and this is 0 comma minus 1, this point, this point. So the graph will look like this. So if I'm gonna draw a neater way of the graph, I'll get up to this only. You might have also seen this in a lot of books. Even on the front covers, this type of graph is drawn. So this kind of easy graph, and one that one must memorize always. So now we'll go to some more complex graph. Y is equal to sine of x. It's a trigonometric function. Sine means, sine is a trigonometric function. I should not tell you in this video, but you must know these things. So in this, sine function is like this. You have to memorize this, or else I'm gonna teach you trigonometry to know how. Like this. So this is always 1 comma 0, and this is all, this is 0 comma 1, and this is 0 comma minus 1. So the sine function oscillates in this boundaries, 0 comma 1 and 0 comma minus 1. It keeps on oscillating, it never ends. Like this, it keeps on oscillating, and in the same way it oscillates in the negative direction also, like this, like this, like this. Well, for the values of x, I'm going to tell you this is sine 90 is 1, so it is pi by 2, and this is pi, this is 3 pi by 2, this is 2 pi. Same goes like this, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. This is pretty much easy function. You must memorize it for frequent drawings. Next comes y is equal to cos x. Y is equal to cos x is also similar to sin x, but shifted only pi by 2 degrees in the right direction. So it starts like this. It's not sharp, it's curved like this, and goes like this. Figures are not to scale, but the ideas are like this. So I'm going to tell you this is 0, this is 0 comma 1, and this is 0 comma minus 1. So this function also keeps on oscillating. This function also keeps on oscillating between 1 and minus 1 on the y-axis, just like goes like this to the infinity. And the values are like pi by 2, pi, 3 pi by 2, 2 pi, like this. This is minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. So the cos x and sin x are one of the easiest functions. One more function that I think this covers. So we are going to draw sin x and cos x both on one graph. It will look like this. This is sin x, goes like this, and this is cos x, goes like this. So whenever it is 0, it is maximized. Whenever it is maximized, it is 0. So it goes like this, like this, like this. So I made something wrong here. We can take this much. So whenever sin x is 0, this is cos x, and this is sin x. Whenever sin x is 0, cos x is 1. Whenever sin x is 1, cos x is 0. So it keeps on, it's like shifted pi by 2 radians to the right, or you could say to the left also, because it's symmetrical. So we have drawn both of these graphs, and same goes in the negative direction also. I just made a little mistake on the left side, but you got the idea. Now we'll move on to some functions that I always thought in this video I will cover. Y is equal to f of x is equal to, I'm going to do minus x if x less than 0, x square if x is less than equal to 1, greater than equal to 0, and 1 if x is greater than 1. So now if we are going to draw it, it won't take even a minute. So if x is less than 0, it's gonna go like minus x, and minus x graph is like this for x still less than 0, x square for x less than 1, 1 comma 0, and 0 comma 1. So we'll draw dotted like this. It's going like, it's not going like y is equal to x, it's going like x square, so it will go like this. Then it goes like 1, and y is 1, I mean y is 1 is like this. So we'll rub the helping lines, and we got our graph. This is our graph, required graph. So it didn't even take a minute. We're gonna draw like this and like this. So this was our required graph. Now we'll go to some more complex functions that you might come across in JEE Mains, JEE Advanced, and I don't know, whichever exam you use. Like y is equal to x plus 5 is, y is equal to x is this, and for now x equal to 0, y is 5, so it has shifted 5 units up, like someone has grabbed this line and pushed it 5 units up. So it will become like now 0, 5, and this is minus 5, 0. So whenever x is 0, now y is 5. Whenever x is 1, y is 6. Whenever x is 2, y is 7. And same goes in the negative. Whenever x is minus 5, y becomes 0. So if we are going to make y is equal to x square plus 5, it's gonna go shift in this. So let's try to make it minus 5. So y is equal to x square is like this, and if we're going to make it minus 5, then for x is equal to 0, it's going to go minus 5. So it will start from here, goes like this, the same as it was earlier. So the graph has just shifted minus 5 units below. Now if we're going to take y is equal to x root x plus 5, same goes like this. For now x is equal to y is not 0 but shifted 5 units above, so it will start from here 5 units above, 0, 5. So it's kind of common with all the types. Now we are going to cover is y is equal to root of x plus 4. Y is equal to root of x plus 4. Now here is whenever x is 0, y is 2. So we're going to cover 0, 2. So the graph has shifted 4 units here. I should say when x is equal to minus 4, y is 0. So 4 units shifted to the left, and it goes like this as y is equal to root x was earlier. It's same but shifted 4 units this side. So you got the idea. Now we'll cover some more complex graphs like y is equal to 1 upon x minus 2. Look, see, I have x and y axis, and if I put x is equal to 2, y goes infinity. So for x is equal to 2, y goes infinity means I'm going to draw the helping line like this, and it goes like this. But on this side it has shifted like this, because for x is equal to 2, y is equal to, my asymptote are now parallel to not y-axis but x is equal to 2. Because if I make it 0, earlier y is equal to 1 by x. Whenever I make x is equal to 0, it was y-axis obviously. So in this question I have y is equal to 1 upon x minus 2. So x is equal to 2 is my axis. So this is the axis, and this whole graph is shifted 2 units to this. So I got the idea how we can manipulate our basic structure of the graphs with the requirement of the complex functions. So more complex problems I will cover in the next video, but for this video, thank you guys for watching, and please do subscribe.